For today's lesson, we are going to be writing a quadratic model to a set of data. We're going to be using our calculator today, so please make sure that you have your calculator as you take these notes. I am going to be starting on page 26 of my notebook. Please pick up the sheet of paper and cut it in half. We are first going to start by taking a look at the difference between a linear and a quadratic equation. Remember that the linear equation is y equals mx plus b. A quadratic equation is y equals ax squared plus or minus bx plus or minus c. But notice the difference in the shape of the curves. What we're going to do is we're going to be taking a look at a table of data in our calculator and determine whether or not it's linear or quadratic. So I've done the first one, but I want to show you on my calculator what I did to get this information. So under stat, above it you'll see a list. I'm going to hit stat, and then notice that number 1 says edit. So I'm going to go ahead and hit enter. Underneath here, if there's information, we want to scroll up and hit clear and enter. Up, clear and enter, and this allows me to enter the information into my list. So what I'm going to do is I'm going to type in -2, 0, 1, 3, and 5, and then I'm going to come over to list 2, and that's going to be my y value, -7, -3, -1, 3, and 7. And what I'm going to do is I'm going to then hit stat. And now I want to calculate. I'm not sure if this is a linear model or a quadratic, but I'm going to come down here to lin reg, and what that really means is linear regression. If it's a linear model, it'll give me values for A and for B. So I'm going to hit enter and enter again. And because it gave me values for A and B, I know that I actually have a linear equation and that it is 2x minus 3. We're going to do the same thing for the next set of data. So I'm going to go back to my stat. I'm going to edit. I'm going to clear. And I'm going to type in -3, -2, -1, 0, and 1. And in list 2, I'm going to type my y values, 2, -1, -2, -1, and 2. And I'm going to hit stat and calc, and I'm going to go back to my linear regression, number 4, and I'm going to hit enter twice. And notice there isn't anything in for A or B. That means this is not a linear model. So I'm going to go back to my stat, arrow over to calc, but this time I'm going to do number 5 where it says quad. That's quadratic regression. And I'm going to hit enter and enter again. And this time it gives me a value for A, B, and C. So I can say that my equation is y equals 1x squared plus 2x minus 1. And that it is in fact a quadratic. And then to double check, I'm actually going to go ahead and I'm going to graph this. So -3, so left 3, up 2. -2, 1 goes -2, down 1. -1, -2, so down here. 0, -1, and then 1, 2. And you can see that it is starting to form a U-shaped curve, which is what a quadratic curve looks like. Okay, so I have done 2 for you, and there are a total of 8. So what I would like for you to do is to go ahead and try these 6 on your own, pause the video, and then come back and take a look at what mine look like to compare your answers. As you can see in my answers, I have a few quadratic and a few linear, and again you're using your calculator and typing them into the stat edit feature. clear out any lists that are needed, type it in, and then hit Stat Calc, and you're either going to do 4 or 5 to give you a regression line, which is basically coming up with an equation for a given set of data. If there's a 0 next to your first term, that means that is not the appropriate graph. What we're going to do now is we're going to take a look at the last 2 examples here. There's no graph needed for these, but what we're going to do is we're going to take a set of data and we're going to enter them into our calculator in our edit feature. So I'm going to come up and clear both of my lists. For the computer between 1999 and 2003, I can leave and put in 1999, 2000, or I can decide that this is going to be 0, 1, 2, 3, and 4 if I want, just to make my numbers nicer. So 0, 1, 2, 3, 4. And then for my volume, I have 800, 720, 640, 572, and 480. And we're going to do the same thing, Stat Calc. I'm going to see if it's a linear model by hitting number 4, Enter. And it gave me a value for A and B. So we are going to say that this is a linear model. And the equation is y equals negative 78.8x plus 800. And it says, what's the value of the computer in 2008? Well, I'm not quite sure. So what I'm going to do is I'm going to take this equation and instead of 2008, let's think about how many years after 2003 that would be. That would make x equal to 9. So if I get out of here, if I second quit or clear, I'm going to actually type into my calculator negative 78.8 times 9 plus 800. And I can see that I will have 90.8 0 because we're talking about volume of computers here. So a value of the computer. Now we're going to take a look at our last one, which talks about a coin is thrown off the top of the Statue of Liberty, which is 305 feet from the ground. The height h of the coin after t seconds. So we'll come back over to our edit feature, clear, enter, clear, enter, 0, 1, 2, 3, and 4. That's our seconds. And then the height, 305, 367, 397, 395, and 361. And we're going to Stat Calc. We're going to do number 4. In this case, it gives me a value, again, for the linear and the A and the B, but let's think about the fact that we're throwing a coin. So I want you to think that if you throw something, remember it's going up and then down. So I'm actually going to calculate the quadratic regression. And this time around my numbers are much nicer. And so this is actually going to be a quadratic model instead of a linear model. And my equation is going to be y equals negative 16x plus 78x, I'm sorry, this is squared, plus 78x plus 305. And what's the height after 7 seconds? Let x be 7. And we can calculate that to be 67 feet. So in this case, our x is equal to 7. And so we can take negative 16 times 7 squared plus 78 times 7 and then plus 305. And we get 67 feet. Okay. We're going to take a look at some more of these in class.